where the center of mass of semicircular plate will be. Anybody? Distance OC? 4r by 3 pi. Center of mass should be equal to how much? 4r by 3 pi. Now get into the problem. Just now what we discussed, those things is what you are supposed to apply here. And there's a question. Okay, we'll analyze in this particular problem. You draw the diagram. Meanwhile, I'll. Yeah. Okay, work out. Just I'll give time so that you should think on this. This distance we know it is r. This also r. Don't look there. So whatever you feel, you do it. Whether it's right or wrong, don't bother. Sir, answer right or wrong. So whatever you feel like, the sir rod will move up. Okay, no problem. Write on the first equation. See, I'm books. What happened? They confined themselves only for the rigid rod. This is like a rigid rod, rigid rod. But in exams, they may ask you anything. So once you do for rigid rod, no, immediately open you assume some other object. What are they after that? So you can bring cylinder, you can bring holosphere, hemisphere, solid hemisphere, hemispherical shell, triangular plate, square plate, semicircular plate, quarter circular plate, cone you can bring, and you can discuss the problem. Okay, now let me help you. So first, what will happen? The rod, what type of motion it will describe? It is a hinged about A, no? So will it describe rotational motion? Yes, it is. It will describe rotational motion. Then what are the forces that are acting the weight? And there'll be reaction at the inch. Okay, now I'll proceed with the. So the weight mg will act here. And this is what? Let me write R, that is R. And then how to get into this one. So let this be theta. If this is theta, this should be the theta. And this is the center of mass. I'll write it here. Will there be any reaction? Reaction force, I'll call, because capital R is what we have symbol, no? So let me write Fy like this. So there'll be reaction force. This I'm very sure. Tell me, like, the moment you release, what happens? It's going to have angular acceleration alpha. About what point? About T. So first, we'll try to calculate that particular thing. Angular acceleration. So mg into r. Shall I write directly? Ia alpha. Because mg into r perpendicular. Moment of arm is called as r perpendicular. Mg into OA. If you want, you can write it. So some of you are asking, sir, why capital R? mg into AO should be equal to IA alpha mg. So what is the distance AO is equal to R. Now, high A, do we know moment of inertia about this point? We need some information of moment of inertia about this point, no? How to calculate moment of inertia? I think we should go back to the MI chapter. Moment of, there's no other way. We must know MI chapter. I think semicircular plate. Can you remember yesterday we have discussed? Anybody reply back? Did we complete it semicircular plate also?
Yes, sir.
Yes,
Semicircular.
sir.
Yes, I think we know it. Okay, therefore, okay, refer back that and write it here. So there should be alpha. So what is alpha equal to? mgr by IA. Now, yesterday we did take help of that one. So now we got this alpha. Then because of angular acceleration, it will have tangential acceleration in this direction. A tangential. So what is A tangential? A tangential should be equal to R alpha. What is R? So we know this distance 4R by 3 pi. So therefore cos theta is equal to capital R by small r. So therefore this should become R cos theta alpha. Theta value we can find out, tan theta equal to 4R by 3 pi. So from that we'll get the cos theta. Theta is not, we have assumed theta. We should find out from OA and this one. So what is tan theta? Tan theta should be equal to 4R by 3 pi by R, or 4 by 3 pi. From this, what happened? I should calculate the cos theta, I'll substitute it. So I'll go the A tangential. Okay, what about the reaction forces at the hinge? How to calculate here? Component of this, how you should write it, you know? mg minus fy should be equal to mat cos theta. Then along x-axis, the reaction force Fx should be equal to mat sine theta. There'll be also reaction force along x-axis. The hinge what happened will try to pull the semicircular plate. Of course, it will not move. The reaction is what we are calculating for this position. Component of A tangential, at sine theta will act along x-axis. So that should be the at sine theta. Fx should be equal to m into at sine theta. Then mg minus fi is equal to mat cos theta. So sine theta cos theta we can find out from here, substitute. All that will get the required answer. So I think you have to really make observation. What is that? Sir, you release from rest, why fx has come? You should look at that 80, no? But sir, in this problem, so in this problem, there is no ry, rx, only reaction along y-axis. I think it depends on the rigid body, no? Shape of the rigid body. Because look at the acceleration of center of mass. The moment you release, the center of mass will try to move initially vertically down. It will move vertically down only. So therefore, reaction will not be there along x-axis. But in this problem, look at here. The moment you release what pen, it will try to swing like this. It will try to swing here. The tangential acceleration itself is like this. So therefore, there will be a reaction. So don't generalize anything. Problem to problem, things will be a little bit different and you should analyze here. So don't again generalize anything here. So now I discuss for semicircular plate. What you should do? You should discuss for this triangular plate, square plate. Let it be different. Let it be released and you see what conditions will come. The particles will not have centripetal acceleration in this situation. Reason because there is no angular velocity. The rod is released from rest. When you give angular velocity only, centripetal acceleration will come. Omega naught. I think you should be very careful. Rod, rigid body released from rest, rigid body given angular velocity and released. Things will be different. If it is given angular velocity and released, then the centripetal force will come. M omega naught square L by 2 or centrifugal force. It is released from rest. There's no angular velocity. If I give angular velocity, then you should bring, if I give some angular velocity and release it, then you should bring centripetal force or centrifugal force. Getting the idea? See, I'm telling this one. Torque equal to I alpha. That's what only rotation mechanics. Again, you have to go back to all circular motion, laws of motion, kinematics, work energy theorem, center of mass, conservation of linear momentum. So many other things what you are supposed to apply here. Again, when the when the line AB becomes vertical, I'll ask you what is the angular velocity. Can you work out that? I'm leaving it to students. You're supposed to work out here. So what will be the angular velocity of the plate when the finally when this becomes vertical? I want this angular velocity. How to calculate this? How to calculate this? Center of mass is here, no? So for this, what you're going to write? How much of height it has descended? So earlier it was here, no? I'll just help you with the diagram. The center of mass is here. Now the center of mass finally descended. So how much it is? This is R. So initially it was at a distance, no? So how much center of mass descended? Center of mass has descended, not height, R h, and you have to calculate that h. So we know this distance is how much? 4r by 3 pi. So what is h is equal to? R minus 4r by 3 pi. So decrease in potential energy, mgh should be equal to Ia omega square by 2. Conservation of mechanical energy. Sir, only mg does work. Yes, only weight mg does work. No, sir, what about the reaction forces? They will intersect axis of rotation. Work done by reaction forces will be 0. So only the weight does work. It does rotational work here. Then I'll ask you, what is the linear velocity of this point? What is the linear velocity of this point? Will be like this. What is the linear velocity of center of mass? Linear velocity of center of mass will be like this, not horizontal. Why? I think, say, the problems are unlimited. There's no like a, the moment you say that I know rotation mechanics is gone, end of the story. Different points will have different linear velocity. We know we have calculated smaller. So what is smaller? Smaller will be again r square plus 4r by 3 pi whole square. I'm trying to explain many concepts in one numerical so that you can manage rather than doing many numericals. No, I can ask you when the line AB becomes vertical, then what is the angular velocity of the, what is velocity of center of mass? So you should use this particular formula. If you know Ia z, if you know Ia moment of inertia, substitute, you'll get omega. Then you can calculate linear velocity. So what is VB should be equal to 2r omega. What is VO? R omega. What is VC? R omega. All points on semicircular plate will not have same, well, like a linear velocity will not be in same direction. Different points will be there. How to calculate? Linear velocity should be perpendicular to radius vector. With that, I'm making a guess here. Okay, I'll scroll down.